So I think the most notorious thing, especially when we're talking about with Einstein, maybe we can get into it, is the year 1905. Now, the year
Mm-hmm.
1905 for Albert Einstein was also known as Annus Mirabilis. Now, I might not be pronouncing that correctly, but it translates to Year of Miracles. Now, you might be wondering, well, what is so miraculous about this year and Albert Einstein, right? In this one year, Albert Einstein changed science, basically. Now, most people, it takes them quite some time. But I mean, obviously, I'm not saying that he didn't take a long time to work up to these papers. But in this one year, Albert Einstein released three extraordinary papers that would then go on to revolutionize science. So we can start with the very first one. So in March of 1905, Einstein releases the quantum theory of light. Now, this is quite revolutionary. Now, remember, Max Planck, I keep messing up because it's a German. Max Planck was very famously known about deriving his emission spectrum and radiation spectrum for objects that basically for black bodies, and the Planck spectrum, for example, is very well used in black body radiation. And understanding, when I say black body, I mean any body that has some temperature above absolute zero will emit radiation based on the Planck spectrum. So Planck was huge in that regard, right? Now Einstein comes up and he's like, well, let's try and see if we can apply this to light as well. If we can try and break up light, because remember, at this time, light was thought of simply to be a wave, right? It was kind of known that all electrons, or not known, but it was thought that, again, atoms and electrons weren't really a thing. So any subatomic particles were... Sorry?
That's not perfectly accurate.
What's up?
You said that at the time, light was thought of as a wave.
As a wave.
But that's not true, actually. Like,
wave particle duality was in
further,
1920. In 1923, that was later.
Even further back, like in the 1700s, Newton actually thought that light was a particle. And then also people like Christian Huygens. I don't know how to pronounce it.
Huygens.
But sure. With the double slit experiment, he concluded that light was a wave. But it's still...
No, but that was later. That was 1923. That was later.
To that point. Sorry?
Yeah, because again, the Newton thing... The Newton thing, obviously...
experiment was in 1923.
Young's double slit experiment, the whole wave-particle duality was after Einstein had already proposed that light was available in packets, right? Because the whole quantum theory of light in 1905... had proved that
I think that's very false.
What? I'm quite sure that the double slit experiment occurred after. I mean, to be honest, I could be wrong. Maybe you can show me, but I'm pretty sure that.
I'll Google it.
When was the double slit experiment?
Thomas Young in 1801.
Oh, 1801? What was I reading? Was 1925. I was in 1923. I read the wave particle nature of light.
1927 was Davison and Germer demonstrated that electrons have the same behavior.
Oh, well, I guess that was a little later. But, well, again, a big part of Einstein's quantum theory of light, was basically classifying light into these packets of quanta. Basically saying that, light doesn't travel continuously, but it has a discrete spectrum. And this discrete spectrum he devised using the Planck spectrum. So if you actually see the energy equation for light, it has discrete intervals of Planck's constant times frequency, hf. So E equals hf is like a very famous equation that Einstein came up with in this quantum theory of light. And again, maybe clearly I stand corrected. He wasn't the first one to prove that, or to show that it came in packets. But what he did was he defined this definite spectrum that light will always follow. And that was a very important idea to then discover the photoelectric effect, right? The photoelectric effect is basically when light hits a certain metal with what is called a work function, but basically a metal with a certain, with certain properties, let me just say that. If light hits it at a certain energy, at a certain frequency, the metal will emit electrons. So you are able to run those electrons through a wire and then we'll get electricity. So basically the idea of a photovalve, or like your solar panels, was come from the photoelectric effect, which again comes from the fact that light travels in these discrete quantities, right? So that was a big thing that he did that was one of his first papers. And one thing I did want to mention, I did search it up, and yeah, so Einstein was actually the very first one to prove that it does come in particles. Newton had thought about it. The wave particle duality nature of Young's double slit experiment was actually shown in 1925, but even though the experiment was done in 1801, it was basically just showing that light and electrons could be thought of as waves. It wasn't showing that they could be thought of as particles.
Yeah.
So that whole particle thing started with the
the
quantum theory of light that Einstein released.
So what you were saying was that before Einstein, people thought of light as just a wave, and I was saying that's not true. Some people thought it was
okay. Well, yeah, some people thought, but there was no proof. What I'm saying is there was no actual proof behind the fact that it was a wave, that was a particle. And then Einstein came out and was like, "Yo, it is." So yeah, so I wasn't entirely wrong. It's just that so the double slit experiment had happened before. It's just that the wave particle nature had come in a little bit later.